Hello everyone, this is an introduction to angles, and in the upcoming videos we will discuss about the calculations that are involved. So if I have two parallel lines and let's say these two lines are transected with another line which we call the transversal. So we will be able to have different angles as you can see. This is angle A, let's call this angle B, let's call this angle C, this angle D, angle E, angle F, angle G, and angle H. We first want to discuss what we call corresponding angles. From this diagram, B and F are corresponding, A and E are corresponding because they appear on the same side of the transversal line and each of them is above a horizontal line. So, I repeat myself, A and E are corresponding, B and F are corresponding. One of the most important things regarding corresponding angles is that the two angles must be on the same side of the transversal, okay? And if we look at F and B, they are both above a line. So the same thing, C and H are also corresponding because they are on the same side of the transversal but below the two parallel lines. Okay, so remember, this is the two parallel lines we're talking about. In the same vein, D and G are also corresponding. So let's try to write the corresponding angles. For corresponding angles, they are equal. So A is equal to E, B is equal to F, C is equal to H, D is equal to G. Okay, these are the corresponding angles that we can identify. Then moving on to what we call alternate angles. One thing you need to know about alternate angles is that they face each other in opposite direction, okay? And they are in the form of, let's say, is the Z. So if this is angle X, this is angle Y, they are alternate angles, okay? So you look for where you can have the shape Z. So the two angles that face each other opposite, they are alternate angles. Similarly, if I have it this way, this angle, let's call it A, this angle, let's call it B, they are alternate angles. So the Z shape that you see is applicable for alternate angles, all right? So if we should go back to our diagram, the Z shape, if we trace it, C and F are alternate angles, so they are equal. Whatever the value of C is, that is the same value for F. And in the same vein, D and E are alternate angles, okay? So C is equal to F because they are alternate angles, and D is equal to E because of the theorem that states that alternate angles are equal. So we will now discuss about co-interior angles. For co-interior angles, if you have two parallel lines, so the two angles that are facing each other must be equal to 180 degrees. That is the theorem for co-interior angles. So let's say this is X, this is Y, this is P, this is Q. So P plus Q is equal to 180 degrees because of the theorem that states that co-interior angles add up to 180 degrees. Co-interior. The same vein, these two angles X and Y, if you add them together, you should have 180 degrees. X plus Y is equal to 180 degrees because they are co-interior. Okay? They are co-interior angles. So let's try to identify that from the diagram. So which two angles will be co-interior? D and F will be co-interior, and C and E will also be co-interior. Remember, for them to be co-interior, they have to be on the same side of the transversal. Okay, this line is the transversal. These two lines are parallel lines. So for them to be considered as co-interior angles, they have to be on the same side of the transversal, okay, and they are facing each other. So for co-interior angles, the property is that D plus F is equal to 180 degrees. Likewise, C plus E is also equal to 180 degrees. Okay? Then we move to another property called angles on a straight line. So if I have a straight line like this, and I have a line that comes like this, then I form an angle. So let's call them angle A and angle B. This theorem states that A plus B must be equal to 180 degrees if you are referring to angles on a straight line. So this is the straight line. The two angles that make it on this line will be equal to 180 degrees. It can be more than two angles sometimes. So you can also have it this way. Let's say this is the line. Then you have a line coming like this and another line coming like this. So we have angles A, let's call this one B, and C. So it means A plus B plus C is equal to 180 degrees because the total sum of these angles will be 180 degrees. So let's try to identify that from our diagram. Now, considering our diagram, if this is a straight line, the angles on the straight line we have A and B. So A plus B will be 180 degrees. Likewise, C and D are also angles on this straight line, so they will make up 180 degrees. E and F are also angles on a straight line. H and G are also angles on a straight line. But if I consider this line as well, it means H and E are angles on a straight line, G and F are angles on a straight line, A and C are also angles on a straight line, as well as B and D. So the theorem is that angles on a straight line will add up to 180 degrees. So we can say A plus B is equal to 180 degrees, B plus D is equal to 180 degrees, A plus C is equal to 180 degrees, as well as C plus D is also equal to 180 degrees. Again, E plus F is equal to 180 degrees, F plus G is equal to 180 degrees, G plus H is equal to 180 degrees. E plus H is also equal to 180 degrees. Because of the theorem, angles on a straight line makes up 180 degrees. Then we move on to another theorem, which is vertically opposite angles. Vertically opposite angles. And what are vertically opposite angles? If we have two lines that cross each other, let's say we have a line like this and another line like this. These two lines, they cross each other, and we have, let's say, angles A, B, C, and D. So A and B are called vertically opposite angles, while C and D are also called vertically opposite angles. Remember, for vertically opposite angles, they are going to be equal angles. So it means A will be equal to B, C will be equal to D. Okay? All right. So if we should identify those in this diagram, the vertically opposite angles are F and H, E and G, B and C, A and D. Those are vertically opposite angles. And the theorem states that vertically opposite angles are equal. So let's write that. For vertically opposite angles, A is equal to D, B is equal to C, E is equal to G, and H is equal to F. These are vertically opposite angles. Then we move on to what we call angles at a point. Angles at a point. So if I have different lines intersecting, let's say we have a line like this, another line like this, then another line like this. We have a point here, right, where these lines meet. So the whole angle around this point will make up 360 degrees. Let's call this angle A, this angle B, angle C, angle D, angle E, and angle F. So they form a circle, okay? So A plus B plus C plus D plus E plus F is equal to 360 degrees because of the theorem angles at a point are equal to 360 degrees. All right? So if we should identify that from our diagram, we have two important points here. One is this one, and the other one is this one. So the total angles that you have around will be 360 degrees. So what can we say? A plus B plus C plus D is equal to 360 degrees. And also we can say E plus F plus G plus H is equal to 360 degrees. These are angles at a point. So moving on to angles at right angle. If we have two lines that we have like this, and let's say the angle between these two lines is 90 degrees, which means right angle. Then if we should have a line that should bisect these two lines, let's say that line comes like this, Then the angles that we have, let's call them A and B. A plus B must be equal to 90 degrees. This is what we mean by right angles. Okay, so angles at right angle. So if you have a right angle like this, A plus B will be equal to 90 degrees. Now we can move on to triangles. Okay, we can have a right angle triangle and the shape of the right angle triangle looks like this. All right, so the angles that we have can be A, B, and this angle is automatically 90 degrees. One thing you have to understand is for a right angle triangle, the total angle that you have, that is A plus B plus 90 degrees, must be equal to 180 degrees, because like any other triangle, the sum of the angles of a triangle must be equal to 180 degrees. Okay, sum of the angles in a triangle. All right, must be equal to 180 degrees. Moving on, if we have what we call an equilateral triangle, equilateral triangle. For an equilateral triangle, if we have the angles, let's call them A, B, and C, you have to know that all the sides are equal for an equilateral triangle. Okay? All the sides are equal and all the angles are also equal. That is the property of an equilateral triangle. So, how do we indicate that all the sides are equal? We're going to have lines that are indicated as shown in the diagram. Okay? So, when you see a triangle and you see that all the three sides have this line, it means that all the sides are equal and also the angles are also equal. So for an equilateral triangle, all the sides are equal and all the angles are equal. And we know that for any triangle, the total angle must be equal to 180 degrees. So which means each is 60 degrees, right? We know that angle A is equal to angle B is equal to angle C, and each angle is equal to 60 degrees. Okay, that is specific for equilateral triangles. Each of these angles is 60 degrees. For equilateral triangle, all the three sides are equal, so we indicate that with these lines that you can see. We have a triangle here and it has all the three sides indicated with a line, indicating that all the three sides are equal. Moving on to another type of triangle that is called isosceles triangle. Okay, so what is an isosceles triangle? This is how an isosceles triangle looks like. It has two of its sides equal. So an isosceles triangle is a triangle with two equal sides and also with two equal angles. And how do you identify an isosceles triangle? Because two of its sides are equal, it will be indicated with two lines. Okay, you're going to see two stroke lines on the triangle that we can indicate like this and this. So as you can see, we have a triangle here and we have two lines on it. It means that two of its sides are equal. This side is equal to this side, but you have an unequal side, which is this side. So if we should have the angles as A, B, and C, the two angles that are on the base of the triangle will be equal. So this is what we call the base, and the other two sides we call that the leg of the triangle. So if this is the base of the triangle, the two angles on the base of the triangle are the ones that are equal. So A is equal to B because they are two equal sides of an isosceles triangle. But what is important to note is that as a property for all triangles, A plus B plus C is equal to 180 degrees because the total angle of a triangle is equal to 180 degrees. That is a rule that implies for all triangles, okay, irrespective of the shape of the triangle, whether it is a right angle triangle, an equilateral triangle, an isosceles triangle, or even a scalene triangle, which is a triangle with none of the sides are equal. Okay? So that is the triangle that we are going to discuss now, scalene triangle. So how do you have a scalene triangle? Let's try to indicate the shape here. This diagram is the shape of a scalene triangle. And if you can realize that none of the sides is equal, and therefore the angles will also not be equal. So what can we say about it? Say that all the three sides are of different lengths the three angles are not equal. So if this is angle A, this is angle B, this is angle C, angle A is not equal to angle B, and angle B is not equal to angle C. Okay? That is a property of a scalene triangle. Thank you very much for watching this video. We will solve plane geometry problems in the coming videos. Please do not forget to subscribe and like the video.